Hello. So today we're going to talk about wave. So as an extension of pendulum. Okay. So pendulum, it's oscillating back and forth, right? So wave, it's also doing oscillation, but it's different kind of motion. But we wanted to study in a wave, which can have different type of wave, and what does wave behave? Say water wave, sound wave, and a wave by a rope. So that's what we're going to talk about. So first of all, we want to talk about two different kind of wave. One is longitudinal wave. So that in Chinese is 横波, right? Longitudinal means 横, okay? So in a longitudinal wave, the wave motion in this case is going left and right. And also its energy, it's going left and right. And the media motion, the media is any point that's the media here is so that's a spring. It's a spring right here. So the spring is your media, and media in Chinese is 媒介. Okay. So this media is also going left and right. Okay, as you shake it, you know, like this. Okay. So that's a longitudinal wave. In the transverse wave, this is a transverse wave. Transverse, right? Transverse wave. This is 纵波, right? 纵波, okay? So what you do is going like this, okay? Like you shake it up and down like that, okay? Then you create something like that. In this case, if you look at one point in the spring, it's going up and down. Okay, so 纵波, right? So you will shake it up and down, and your media, any point, a particle or an atom, it's going up and down like this. The media motion is going up and down when your wave motion and your energy is going left and right. Okay, so that is called transverse wave. When this transverse, media motion is 90 degrees. So media motion is 90 degrees to the wave motion. Okay, but in this case, they are parallel. Wave, it's parallel to the media motion. Okay, motion. I'm talking about motion here. It's just kind of lazy, didn't write it. All this are motion here. Okay, so that's the basic introduction of two type of wave. Longitudinal wave and transverse wave. Okay, so to continue, we're gonna discuss another two type of wave, which is basically different way of looking at wave category. So EM wave is one kind of wave, and EM wave, it's a transverse wave always. Okay, so EM wave has a spectrum of different type of wave, and it goes from radio wave, which has the largest lambda. Okay, so lambda pronounced here as lambda, L-A-M-D-A, which is large on this side, and we have gamma wave on this side. The gamma wave is high energy and is dangerous. So this one here is also written as gamma like that. So this one here is small wavelengths. Okay, this lambda, it's called wavelengths. Okay, so in the transverse wave, when we draw it like this, so you have crest. This is called crest or peak. just different word, but means the same thing. And then you have this one here, you can call that valley or trough. Sounds like the fish trough, but it just means valley here. So low point, and this is a high point, right? So when we say wavelengths, we're talking about changing color here, talking about from here to here, for example. That's one way to look at it. That's your lambda right there. You can also look at from here, say from here to here, okay? That's also your lambda right there. That's your wavelengths, okay? And the unit for that is meter, right? So the unit for lambda is in meter. Okay, so this is EM wave, and in the middle we have visible light right there. This very small region here is a visible light. So in Chinese means 可见光. Means that our human can see this well. All right, and this range here goes from about 400 to about 750 nanometer, right? So I should write this on this side. This is 400 nanometer. So nano, it's 10 to the negative 9, okay? In Chinese, this is 9, okay? Nanometer means 9, all right? So that's the EM wave, and they all transverse wave. So EM wave has a specialty, as a special EM wave does not require media. EM wave, what's special about EM wave is that it's a transverse wave, but it does not require media. Does not need media. Okay? And the EM wave always travel in the speed of c, which is light speed. And that's equal to 3 times 10 to the 8 meter per second. Speed of light. Okay? So all of them, okay, all of them, including radio and visible light, and right here you have microwave, and then you have infrared, okay, also called IR, right? IR. So in Chinese it's called 红外线. Okay, infrared wave. And then you have visible, and then you have UV, also called ultraviolet, right? Ultraviolet. Okay, and this in Chinese is called 紫外线. Okay, and after that you have X-ray, okay, X-ray, and then you have gamma wave. So that's your EM wave, and all of them travel in 3 times 10 to the 8, and lambda is largest on this side. This can be like 1,000 meters, for example. So like between here and here, this can be 1,000 meters, okay? That's very large for radio wave. So 10 to the 3 meter, okay? And this side here is already very small right there. You know, if you look at gamma wave, it's going to be even less, like maybe like a 10 to the negative 15. Right? And for the frequency, it's just the opposite. So frequency here, the frequency also written as F. I'm going to change in color here so it's a little bit easy to see. Frequency, right? This side here is fast. Oh, sorry, this side here is slow. Okay, so this unit is in terms of hertz. And this side here is fast. So this is fast. All right, so in terms of energy, you're going to change in color again, changing color to this here. So for the energy, I apologize for, so this is energy. This side here is high energy, right? So you don't want to get burned by gamma wave. They will kill your cell, right? And this is low energy, right? So if you have radio wave bump into your body, it's harmless. So that's why we work a lot with radio, yeah, because it's very harmless, and we're also using microwave in the kitchen. But you know, infrared starting to get a little bit, you know, tricky. But I'll, you know, so here it's still okay. But after the visible violet light, the UV and on, this one here, according to medical society, this is dangerous because it's high energy. All right, so that's EM wave, and I'll talk a little bit more about other wave. I'm going to clear that. I'm going to talk about mechanical wave. So mechanical wave require media. Okay, so that's your characteristics. Require media. Okay, 机械波, right, in Chinese. Okay, so let's say a rope, right? A rope wave, right? A rope wave typically looks like this. Okay, so this mechanical wave, it can be either transverse or longitudinal. Okay, transverse, right? So it 可以是纵波, right? So in Chinese, this is 纵波, right? And this is a 横波, right? So it can be either one. In rope, you have this, right? And let's say you have sun. Sun is also a mechanical wave, right? But the important thing is it requires media. So this one here, the media is the rope, right? The media here is the rope, obviously, right? And in the sun, the media here is the air. So let's say if you talk in the vacuum, right? If you can create a vacuum, this is a vacuum. So vacuum. Vacuum in Chinese called 真空, right? 真空, right? So if you can create a vacuum and then you put your speaker inside here, this is your speaker, and you try to using electric signal, and somebody put in their ear there. Okay, this is your ear. Not a very good drawing there. You create a sound wave. This ear cannot hear it because there's no air. Okay, so this one here, the media is air, right? You can have water wave, for example, right? So then the media is water, right? Okay, or ocean wave, right? So this are mechanical wave. The important thing is it requires media. All right, so we're going to stop there, and that's what we have talked about today. We have different category of wave, right? Category or type of wave, TYPE, right? Type of wave today. Okay, and we talk about transverse, right, versus longitudinal, right? And then we talk about mechanical wave, right, versus EM wave. Okay, and this one here is 90 degree, right? The wave and the media. And this one here is parallel, right? The wave motion and the media motion. And this one here is that it requires media. And this one here says it's no media, right? All right, so that's the summary of it. And we're going to stop there. If you like it, subscribe and 订阅, okay? And like it, and we'll keep doing it. Bye-bye.